Hey, hi Natasha. This is Sagar. Am I audible?
Yes, hello.
Hey,
Yes.
hi. I just want to ask actually, one of my friend was also interested to this attend this, but unfortunately he had to travel. So I saw that the recording is being done. So this will be shared across the mail IDs or where exactly?
Arjun, maybe you can answer that. I'm not, actually, I'm just speaking. I'm not the organizer.
Sorry, yes. Then I think that question would be for Arjun.
Yes, so recording will be shared on LinkedIn and also on our meetup page.
Perfect. Thanks for the information.
So good morning, everyone. It's absolute pleasure to welcome you all of you today online session AI powered Swift app tool technique and best practice. We are thrilled to have such a fantastic audience, developer, tech enthusiast, and innovator joining from different part from the world. And before we begin, let me introduce myself. I'm Arjun, your host for this event, and we have explored how AI is revolutionized in iOS development, how Swift developer can utilize an AI into the AI iOS app. Before we dive in, we quick tech check. So please make sure your audio is yourself mute. We have a QA session, so we can ask question in our QA session. And if you have any question during the session, please request to speaker and ask. And also, we are big thank you to our attendants taking a time and be part of insight and discussing. Also, specialist thank to our guest speaker Natasha and as a joining our event. Yeah. So now, without further delay, it's my honor to invite our speaker Natasha, who is an expert in mobile development and famous blogger. Please join and welcome Natasha. Feel free to use the reaction and give the yeah. Natasha, this is your session. We are eager to learn from your experience and insight. Let's dive in.
Okay, thank you, Arjun. Thanks everyone for attending on a Saturday. I think Arjun mentioned that usually these sessions are about 30 minutes, but with AI, there's just so much to learn. So this will be probably like 2 hours. Yep. I think Arjun, if you can mute, there's a little bit echo. Yeah, so the session will be like, so there's a lot to go over. It'll be very fast. So I do encourage you to ask questions. This is a bit of a bigger group, but uh, I guess it's Saturday. So if needed, it's also recorded so you can ask your questions that you have. So I'll just start by sharing my screen. Can everyone see my screen? Yes. Great. So I have, I think, yeah, many people like to chat, but it's a bit difficult for me with chat because the sharing on one computer, it's hard for me to see the chat. So please, if you do have questions, please just say them out loud, and I'll try to stop during different parts in the presentation and ask for questions. So for those of you who don't know me, my name is Natasha, and on Twitter or X or just social media, I go by Natasha the Robot. I have a blog, natashatherobot.com, and I run Try Swift, which is a conference that's around the world. So we've done it in New York, Tokyo, and one time in Bangalore. And I think someone is speaking. Yeah, Arjun, if you can manage muting people, yeah, if there's noise. I know it's sometime you join and the mic goes off. Yes, so I wanted to first share my journey with AI. So actually, I've been living in India now for 4 years, and the reason I've been living here is because I've been studying Sanskrit language and Ayurveda and like Mahabharata, Ramayana, different ancient texts. And I like to learn them in the original language. So I finished the master's in Sanskrit studies from Manipal University, maybe like about 1.5 years ago. And this is when AI came out. So this was very exciting for me because Sanskrit is like the perfect like language for AI because it requires kind of large computation and combination of words and breaking down the grammar. So I was very interested to build AI tools for people like me who are trying to reach shlokas. So that's kind of what I've been working on from the AI side. I also have been working with Vatsal Mano. Many of you might know him. He is running a company called Preternatural AI in San Francisco, and he's focused on building AI tools for Swift developers. So this is my AI background. And yeah, I think the Swift community has taken much longer time to adapt and start integrating and learning AI, which I think is a mistake because it just empowers, so many user interfaces that could only be mobile. And I don't think chat is like the main interface. So there's a lot of opportunities right now for creating different types of apps that have not been possible before, including the Sanskrit apps I'm working on. While I was in school and learning it, it was not even possible to make the apps that I have in mind right now. So it's exciting time. If you haven't played around with AI, I highly encourage it. I run workshops also on my company, Try Swift, and then I write blog posts about Swift and AI development. And my goal is always to be, balanced. I know there's a lot of hype cycle because companies are trying to raise a lot of money. So I'm always trying to be practical and playing around with what is possible, what are the limitations, what you should consider. So these are the type of workshops and blog posts that I work with. So I'll go ahead and get started. So the goal of this workshop is more of an introduction to AI, but it'll be intense. So one thing is AI was traditionally in academia. So a lot of the language around, large language models and AI are like super technical. There'll be like fancy terms. And when you read blog posts or you see papers online, they'll use those terms. And if you've never heard of them, it's like intimidating and scary. But a lot of these terms are very easy to understand. They're just fancy terms that academia uses. So my goal is that you catch on to those terms very quickly in this workshop, and then you can explore more on your own and understanding what are they talking about. Again, I want you to understand the possibilities and limitations of LLMs both, because there's so much hype and people are saying, it's AGI, it's like this crazy intelligence that's going to replace all of us. But what is the reality? What are the actual things that should be built? What are the limitations? Where are you going to run into problems? And then I want you to understand the AI ecosystem within the Swift developer tools ecosystem. So this is problematic because most of AI work is done in Python and sometimes like in JavaScript. So the Swift developer toolkit is very small compared to what is out there. So I'll cover a little bit of what's there, but if you are someone who's building tools and you enjoy that type of work, there's just a ton of opportunities to build for Swift developers. And then we'll explore actual projects in Swift. So what you'll find online is most examples will be in Python or web projects, and they won't be applicable to something you would build in Swift. So I will be showing actual code, how you structure your project, how you run the project, and give ideas so that you can get started after this workshop on your own. So before we dive in, I'm going to show you a small video. This is like an amazing, amazing video on YouTube. And this will explain the basics of how AI works. So I'll just get started. It's 3, 1, yeah. So I'll start the video. I might have to share 1 second. I'll stop sharing and then share with audio. There you go. Audio. Great. So hopefully you all can hear the video.
Imagine you happen across a short movie script that describes a scene between a person and their AI assistant. The script has what the person asks the AI, but the AI's response has been torn off. Suppose you also have this powerful magical machine that can take any text and provide a sensible prediction of what word comes next. You could then finish the script by feeding in what you have to the machine, seeing what it would predict to start the AI's answer, and then repeating this over and over with a growing script completing the dialogue. When you interact with a chatbot, this is exactly what's happening. A large language model is a sophisticated mathematical function that predicts what word comes next for any piece of text. Instead of predicting one word with certainty, though, what it does is assign a probability to all possible next words. To build a chatbot, what you do is lay out some text that describes an interaction between a user and a hypothetical AI assistant. You add on whatever the user types in as the first part of that interaction, and then you have the model repeatedly predict the next word that such a hypothetical AI assistant would say in response, and that's what's presented to the user. In doing this, the output tends to look a lot more natural if you allow it to select less likely words along the way at random. So what this means is even though the model itself is deterministic, a given prompt typically gives a different answer each time it's run. Models learn how to make these predictions by processing an enormous amount of text, typically pulled from the internet. For a standard human to read the amount of text that was used to train GPT-3, for example, if they read nonstop 24/7, it would take over 2,600 years. Larger models since then train on much, much more. You can think of training a little bit like tuning the dials on a big machine. The way that a language model behaves is entirely determined by these many different continuous values, usually called parameters or weights. Changing those parameters will change the probabilities that the model gives for the next word on a given input. What puts the large in large language model is how they can have hundreds of billions of these parameters. No human ever deliberately sets those parameters. Instead, they begin at random, meaning the model just outputs gibberish, but they're repeatedly refined based on many example pieces of text. One of these training examples could be just a handful of words.
So I'm just showing you the beginning of this video. It's by 3 Blue, 1 Brown. And I highly recommend, he has a series of these videos showing, all kinds of different, like more advanced topics in a very beautiful visualized way. But what I want you to take away from this is that, you might have played with large language models. You might have used a chatbot like ChatGPT or Claude, and it seems like it's magic. But it is actually a very large auto-completion machine. So, and here he shows how, the model predicts the next word, but it's actually a little bit more complicated where it'll be parts of words. So the model, this creates certain limitations. One thing, of course, that you can think of right off the top of your head is if this model is just giving you the next word, it does not care about truth, for example. It's trained on all of the internet data, but you have to think, is all of the internet data true? So that is one problem. So we all know maybe stories about Wikipedia pages that might have been altered with truth. What is truth at the moment due to politics? So these are the type of things you have to worry about, that large language models are trained on internet data. What is the reality and reliability of that data? Yep. Is someone have a question? Okay. And then the next problem is, it's outputting kind of next words in a sequence. So even if it did read, truthful, what we would say is objective, truthful information, it's kind of just giving what is the next possible word. So it might not actually be true. It's kind of mimicking what it is trained on. So this is called hallucination. You might have experienced that, especially as a Swift developer. If you ask it to code, give you a Swift UI, maybe Swift data methods, it wasn't trained on Swift data is one thing because it has a cutoff date. So it was trained maybe on all the information in 2023, and now it is 2025. So the information it's trained on is already old. It's not the latest information. And if you put something like Swift data, it will still give you the response and it will code and it will look like Swift code. But when you put it into Xcode, you would get an error. So this is called hallucination, right? The model gives you the output, but the model doesn't care that the output is true. So this is something to know when you're creating your applications. So the more you learn about how large language models work, this is when you'll get intuition for how to work with them. The other thing you could see is we're given this user, they created this chat interface. So initially, the large language model was trained in just internet websites, internet documents to just predict the next word. Then after it predicts the next word goes back into the prompt and it predicts what is the next word. So the user AI assistant structure was created by OpenAI. So it kind of forced the structure by having a lot of human workers come up with this user assistant response document. So one thing to realize is while in the UI, it looks like, there's a user, there's an assistant. To the large language models, that is not the case. They just see one document, like they see it as one document and one piece of text that goes in, and it's simply predicting the next word. So one of the cool things you can do is the Anthropic model, Claude, and also if you work with open source models, you can actually start the assistant response. So you can kind of prompt the model to like always say yes, for example. Like you can say AI assistant, yes, comma, right? So whatever the user puts in, it could be a yes model. So there's a lot of kind of assistant hijacking you can do. This is useful for like if you don't want the model to keep saying stuff, you just want code. You can say, start with tick, 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 Swift, like markdown Swift format, and it'll give you just the code next. So this is just something interesting you can do. The other big problem is math. So you could see that this is literally just predicting the next the next word in a series. So this is not a calculator. If there are a lot of math problems available as examples on the internet, that this large language model will be good at it. But if you have like a more complicated and different math question, the model doesn't do math. It's literally working with language. And the units it's working in is not letters. It is literally like parts of words. So you might have seen that there's a famous example where you ask, how many R's are in strawberry, and the model cannot count letters. That is because it's not thinking in letters, it's thinking in like partial words. So these are the issues you have. One interesting example for math is if you ask the model which is bigger, 9.11 or 9.9, it's going to say 911 is bigger. And, so the reason for this, which I watched in another video, one of the OpenAI co-founders had, he explained that somewhere on the internet, they have Bible verses. And in case of Bible verses, 9.11 is higher. It is like chapter or book 9, chapter 11, versus 9.9 is book 9, chapter 9. So in case of Bible verses, 911 is actually bigger than 9.9. So these are the type of things where, the model is not thinking in the same way that we are. And the more you learn, what is it good at and what is it not good at, then you can leverage that information and create more powerful apps and not fall into different traps. That could happen, and the weird use cases that happen because of how this model works. So does anyone have questions about this part? Okay, so I will move on. So now going back to the practical. So what are the tools that we can interact with as developers? And the problem is in the Swift ecosystem, the tools are not great. There's not much. So when you work with a model or like LLM, large language model provider, they will have an API. So the core idea is that you can always create your own client. So you just go to you could Google OpenAI API reference, and it's literally an API. So even though you interact in a chat format and you think, okay, this is complicated how it's working, you don't have to worry about it. You do an API call to OpenAI and it will manage the model and return back the result. So OpenAI has done, just an incredible job creating this interface. You might have heard of MLX Swift. So MLX Swift is a project that is run by Apple. It is open source, and it is meant for running open source models, which are hosted on Hugging Face platform. So Hugging Face is a platform. It's like GitHub for AI models. And it's a lot of models. It's super crazy because you have to know, it's overwhelming which models are good, which are not good. So this is an uncurated source. You can think of it as GitHub, if you're looking for a library for Swift, you don't know, is this a good library? Is this a bad library? You have to download it, test it. But in this case, some of these libraries are like many gigabytes and cannot even be downloaded to your Mac. So it's like a pretty crazy space, but if you wanted to explore more open source models, you can check out Hugging Face and MLX Swift. Now, MLX Swift, running a model is a lot more complicated than what OpenAI provides and these API providers provide. So I'm not going to go into that. You would have to kind of play around with it. They have a lot of examples. Yeah, so they have actual examples of how to run the models. But once you play around with them, then you will realize, wow, like OpenAI and Anthropic and all these model providers have done an incredible job for letting us interface with these models. So
Hi.
yes,
What is the difference between MLX Swift and Core ML?
right. So CoreML is Apple's framework for creating local models. And it's optimized using the Apple's neural engine. So CoreML is like more powerful in terms of like being on device and efficiency for on device models. But the problem is CoreML models are very small and they're like extremely small use cases. So basically, like you could think of Apple is like super behind in uh, just the whole AI space. So CoreML is just the old style AI. It's kind of like, for example, I build an app where you can take a picture and you identify objects in this picture. And I use the YOLO model, CoreML model. Well, this model can only identify 80 items. That's it. So this is the old style machine learning that kind of never took off because it wasn't powerful enough. But maybe you are building an app that's focused only on identifying cats and it's one of the 80 objects that's in this core ML model, then you can use this model. But if you want, like identify anything in my picture, like I'm in India, so one example is like food. These older models, they're trained in US, or like Western world. So it will not be able to identify like a chapati or something. So it might also not know like exotic fruits like mango or banana or like dragon fruit because it's only knows apple and orange. So these core ML models, they're very small, they're very specific, and there you could look into it to see if it works for a very specific use case, but it will not work for like just that large, like any problem that you need to solve that we see in large language models. Does that answer your question?
Yes, sure. Thanks.
Yes. Yeah, and I don't think Apple doesn't have a large language model. So if you use Siri, it doesn't work the same way like OpenAI. It's very limited. You have to say things in a very specific way. You cannot just completely go crazy with natural language. You have to be specific. So these are the older models, but these new large language models, they're like say anything and it will understand and reply. So I mean, it's like a huge, huge breakthrough that has happened in computing, and then we can go ahead and use that. So there's many model providers. So going back to tools. I mentioned before I was working with Vatsal at Preternatural, a company he runs. So Vatsal is building many tools for AI developers. So I just recommend you sign up, and then when he releases his tools, you can be the first one to hear about it because it'll be really cool stuff and very important for both the back end and the front end that's needed for creating, these good AI apps. But right now, this is not in production. So the company I like to use is called AI Proxy, aiproxy.com. And the benefit of using AI proxy is two things. One is kind of the problem we face as Swift developers is storing the API key. So basically, there's no way to securely store an API key on the device because, at the time of the server call, you have to show it. And what happened is many people want to steal these keys because it costs a lot of money to make these API calls. So you have to protect your key. And the way to do that is one, you can build your own server. So if you're working in a large company, then your backend team will create some kind of proxy server where you make an API call to your backend. It's verified and secure. And then that will make a call to the AI API. But what AI proxy does is this is for indie developers. So like let's say I want to build an app and launch tomorrow, and I don't want to build a backend service, proxy service myself. So they build this for you. So you can just log in and store your key, and they will give you a secure like service URL. And they also have device check to make sure that it's like an actual user that's using your app and it's not being abused. So this is just a service for that purpose to just get started. And then the biggest thing is they support many services. So I mentioned like OpenAI, Gemini, Replicate, Perplexity. So this is something when you're working with AI, never commit to one model. Don't be like, oh, I like OpenAI. You have all these models are changing and new things are coming out for pricing. There's cheaper versions coming out, like open source models. So you want to have a system where you're changing models very often, even for testing. So this is nice because they have Swift, specifically Swift examples. So this is for Swift developers where you store your AI key on the server side, and then you can work with any provider. And he has just these quick, examples that you can like start by copying, pasting, and refining. So it's well documented. It's also the library itself is open source. So like yesterday, I contributed to it. So if there's something that's missing in the API provider, like that's not in the AI proxy library, you can actually go in and check, do your own pull request and add it. And I just wanted to go over some other services. So I mentioned OpenAI and Anthropic. I think you guys know for Claude. But one cool product is called Together AI, which they also support. ABC. Okay, here. So there are certain providers now that will take open source models from Hugging Face and curate them. So it's very stressful if you were to go on Hugging Face and say which library is good, which is bad. So Together AI is a product that will include a lot of these models and provide an API for them. So you don't have to do it yourself. And they're going to be much cheaper and faster than OpenAI, and they work well. So for example, this is products, custom interface, library. There you go. So you might have heard of DeepSeek R1, which is this model from China that rivals OpenAI's O1 model. Well, it was hosted on Hugging Face, and you cannot run it locally because it requires too much compute power. But what they do is they host it, and then you can even try the smaller version. So they have many models, the Mistral model, that are open source and extremely powerful, that are OpenAI quality. Like the Llama model is from Facebook. The Quen model is from Alibaba, so it's very strong. They have some free models. So these are tools that are nice because they, one, curate which models are good. And then two, they'll create an API to use those models. that is following the OpenAI standard. So the OpenAI API has become the industry standard, and whenever now somebody releases kind of a new model, they'll just follow that standard for the most part. The other similar product is called Fireworks AI. So they do the same thing. So you can compare with, between these providers, which library is cheaper on which provider. So this is another one. And another provider like this is called Grok. Uh, so they boast that their like models are super, super fast, and they raised a lot of money. So you have many options. You're not stuck with just OpenAI. And when you're looking at price sensitivity, then these products might work well for your use case. And you don't have to worry about, paying as much for like OpenAI or Anthropic. You can get a fraction of the cost and use Grok. The other products, again, that are similar are for open source models that also include visual and movie models. It's called Fall AI. I think my internet is more slow. Okay. Yeah. So you can explore, and Fall AI has like a lot of visual models. So you can like kind of find image to video. I want text to image models, and they have a very nice interface where you can go in and like see the output, and they will give you the code, and they have Swift option. So Fall AI also has a Swift client, so you can also explore that. But the problem is, again, your API key. You have to be careful with that. But if you wanted to quickly test out Fall AI, you can try out this model. But AI proxy does support Fall AI as well, and it'll store your API key. So this is Fall AI. The other company is called Replicate. And Replicate was one of the co-founders for it is Matt Thompson, who ran the NS Hipster website, like very technical blog. So he created, like, initially it was a Swift API, but now he has like more Python and HTTP, but there's still a Replicate Swift library that's available. So you can that's like easy to work, and this is created by Matt Thompson. So you can just specify, which model you want to run and your prompt and get the prediction. So these are the different options available. Does anyone have questions about this?
Hi, Natasha. So
Yes,
these are just models that we can use now, right? Like we don't need a OpenAI API. These are just models that
exactly.
we are getting that without deploying into our project, right?
Yes. So actually, these are like APIs to use the model. Yes,
Okay, so
exactly.
there are curated list of different APIs that we just have to follow the API keys, provide
Mhm.
and by securing into either in a server or a proxy, and
Exactly.
without deploying into our server, like Hugging Face
Well,
probably.
you can also, if you have a backend team and you're interested, you could deploy the model yourself. Not OpenAI. So OpenAI and Claude are closed source, but the models on Together AI, they're open source on Hugging Face. So anyone can take that model and deploy it on their own server and have complete privacy.
Okay, thank you.
Yes, thank you. I'll just check the chat. Can DeepSeek models can be used MLX Swift? So DeepSeek, the big model, the R1, is like at like 500 gigabytes. So the problem is not MLX Swift. It is actually just you don't have space on your Mac to run it. So that one cannot be run unless you like stack Mac minis and like go crazy with it. So DeepSeek is available on open source. It could be deployed. It does require like a NVIDIA disk to run it. But DeepSeek also has a smaller distill model, which you saw was free on Together AI. So that model you can run with MLX Swift. But again, I'm just going to repeat that when you run models with MLX Swift, it is not going to be as nice as the APIs. You're going to have to do like a lot of grunt work to get the model even running, and you have to have a lot more knowledge. So you can try it, but it's difficult, but it's definitely possible for smaller models. Yeah. Oh, great. Let's approve. Great. Okay.
I have just, sorry to interrupt. I have
Yes.
one quick question. I'm very new in the AI. So my question
Mhm.
is that like in which cases someone should deploy any of this model to their own server instead of just using the API keys. If my thought is like, is it when you need the specific customization, then only, or like what are the reasons people deploy on their own server or even
Yeah.
train that or
Yes.
model?
Yes. Yes, so to deploy on your own server, the reason would be one for privacy. So when you're using the OpenAI API, every data point, every API call, every request is sent to the OpenAI server. So let's say you're making like a tax app or like a finances app. Then every time you're gonna have to send like users' personal financial data to OpenAI, and they don't have any, I'm sure they're not going to release it to everyone, but they're going to be using that data to train future models. So this is a big concern for security. The other reason would be cost. So, each time you send a message and get back a response to an like AI API provider, there's going to be some money that you have to pay. So one, like to save money, then you would do your own server. And then the other reason would be like rate limits. So OpenAI is pretty good, or like Google is really good. But if you use many Grok libraries or Together AI libraries, they're going to have a rate limit. So that's something, if you want more control and user privacy, you would do your own model deployment. Um, if you're just an indie dev and you don't feel like your app is about user privacy and it's not a big deal, then you can use these APIs. For training your own model, that would take like a lot of money. So this is just for, very big companies like X, OpenAI, like Google, Meta. This takes like millions and millions of dollars of training, DeepSeek. So your company would have to be super big to train their own model. You can also kind of fine tune each model, which is like you kind of give it the format you want your response in. So fine tuning is available and it's like okay to do, but I would only do it if like you're not able to get the response you want. So first you would test different prompts, different models, and then see what is the output. And then if you need like something different that's not happening with the model itself, then you can go ahead and kind of give it examples of what you want and then fine tune it in that way. Does that make sense?
Yes, absolutely. Thank you so much. Very good answer. Mhm.
Yeah, thank you. We'll go back. I think one more chat. Great meetup page. Mhm. Yeah, so someone mentioned also they want to see an example. So definitely we'll be going through examples of everything, but I wanted for you to understand the basics. So the first example is going to be a very simple. This is kind of like a hello world for AI apps example. It just write a poem about any topic. So as we mentioned, like LLMs are very good at predicting next words. So if you have an app for creative writing, this is a very good fit. You don't have to like worry about any issues. And I'll just show you how that works. So you just say, I want to write about a Swift programming language, and it will write like a nice poem. So this is the best use case for AI, anything creative. And I'm sorry, my internet might be slow today, but it writes a very nice poem. So it's also good like for brainstorming, like something where you don't need facts, right? You just want creative writing, but you're not focused on like, I want historically accurate facts because AI may hallucinate information. Yes. Anyone have questions? Okay. So how do we build this? So I'm not going to go over the Swift part of the code because you know how to make the interface. I'm going to be focused on AI. So usually like this is the app, this is just the UI part. And now I'll usually have like an LLM manager. And this is where I'm using the AI proxy library. You just import package AI proxy into your app. And then I create an open AI service. And I just got this code from AI proxy documentation. So it's as simple as this. Note that for demo purposes and to quickly test, I'm just using, my straight up OpenAI key. But they have, once you go to AI proxy, you can go through all the steps to upload your key, and then you will get a protected way of initiating the service. So you can look up this yourself. One thing to note is that in order to run these APIs, even for testing, you need to put a little bit of money into OpenAI. So first you will sign up. Then you add maybe like $5, like 500 rupees, and then you can test the system. If you don't have money set up, it will not work. I then specify the model. In this case, I'm going to use GPT 4o. And then I'm going to specify the system prompt. So the system prompt gives the AI, like the large language model, like overall instructions of what it's doing. And if you're interested for prompt engineering, you can Google, leaked prompts. And there's a GitHub repo where you can study these. So even though we have this magical experience with AI where you put in anything and it gives you the right answer, you have to remember that it's trained on website data. So you have to match, whatever is you think the LLM is trained on in your topic. You want to match that type of language to get more efficient results. And there's a lot of quirks which are like very funny to us. But one thing is if you say, you are a helpful, famous poet assistant who excels at creating witty and profound verses for discerning readers. So if you put this line saying, you are expert in Swift, you are expert in this topic, you are an analyst, then the AI will do better than if it just doesn't have that first. So this is kind of like a funny thing, even though the large language model knows everything from the internet, you have to tell it that it's good at, you're a history professor. So you have to give it this personality. And the way I generate this system prompt in general is I use Claude, or like you can use ChatGPT, and I literally tell it, I'm building an app that will write poetry, write me a prompt, because you have to like be very specific. And then what I will do is I will paste it, then I will read it, and I will edit it, what makes sense, what doesn't make sense. I will also then run the app, and then there's going to be some quirks or missing things or funny things happening. Then I will add that to the prompt to make sure that doesn't happen. So here, like I am a writer, but this is kind of, it needs a little bit more imagination and interesting stuff about poetry. So it was nice that Claude wrote it for me. Claude or Anthropic also has a tool for testing and generating prompts that you can explore. So here it came up, this is my poetry themes. And it gives guidelines. So this was very nice. I also wanted it to be shorter, so you might have to tell it be shorter, don't use complex language. So this is kind of basically the main system prompt, where you say, this is what this project is about. Then the user enters a poetry topic, like write about poem about Swift programming languages, and then you have the user prompt. So the user prompt is more specific, local, versus the system prompt is the general prompt. So this will say, write a poem about whatever topic the user put. And then all I do is I make a chat completion request. So remember that LLMs are autocomplete machines. So initially, there was no chat. It was just completion request, because you just put in text and it gives back an answer. But what happened was that product didn't work. So chat format won over. So even though in this app, there's no direct chatting, as you see from the interface, I'm just literally, the user is not even aware that there's a chat happening, right? But in the backend, we have to, even if you're just giving me one response back, it is a chat completion request. So what happens is, the LLM will take the system prompt, and then it will take the user prompt, and it will come back with an assistant prompt. So just like you saw in that video, it will start AI assistant, and then the language model will give back the response. Then all you do is you get back the poem string. So this is literally like all it takes to interact with OpenAI. That's it. Just a few lines of code when you use this AI proxy library. If you write your own, then you would, go to the API documentation, and you would create, a post chat completions endpoint, and you would follow these inputs as you need. And it's very well documented. So one person in another workshop, they literally took this page, and they even had Claude write like this OpenAI chat completions client for them. So it's very easy to do. Yeah, that's it. And then you can basically catch errors, handle errors as you need. Does anyone have questions about this?
Yes, hi, Natasha. Uh, I think Chat GPT does not record or keep history of the messages. So how do we do that?
Exactly. So as you saw in the video, um, and we'll have another example that does this, but as you saw in the video, the LLM, it is not something that has memory. It literally will take one text block as an input, and it outputs the next word. That's all it does. It does not remember any conversation. So what you have to do is you have to keep track of the conversation, the user and assistant reply in your own app. So if I had a chat, then I would say assistant, and then I would like put, this is assistant text. This was the assistant reply. I would keep track of every reply, and then, right? And then I would continue on. Assistant replied this. Then the user replied something else. So I have to locally in Swift using Swift data or file storage or backend service keep track of the conversation. And every time I make a call to the model, I have to send it every single message every single time.
Will this increase the token consumption?
Yes. Yeah, so token like consumption just means, every text uh and it's not even words, but you can think of it as words, but every word you're sending is like a token. But it's gonna be more like help might be one token, full might be another token. So anything you send it will be considered a token. The nice thing is now, like OpenAI and Gemini are adding prompt caching. So now, it'll be less tokens because the first time you send this prompt, it will not be cached. Like every token will be counted. But then if you keep kind of sending it in a short term, like messaging chat format, then it will store it temporarily as a cache. And then your token consumption will be less in that way. But yeah, in general, anything you add is going to be added as tokens.
Hey, hi, I have a question. So we can see that GPT-4 is being used here. So can we specify that I want GPT-3 or the latest GPT, let's say the 4.5 comes in or 5 comes in. Can we specify here
Yeah,
the version we want?
exactly. So here I specified the models. So you can say, GPT-3, you have to find the exact names on the uh, AI providers documentation. So I think it's GPT 3.5, but you basically specify which model you want. Yes.
Okay, thanks.
Yep.
Hey, hi
I
Natasha.
have sorry, go ahead, please.
Yeah, I'm having one question. As you mentioned, this works as a chat mechanism, right? So how does the interaction between the client and the server, means the model happens? Is it based on the WebSocket, or is it like the way we are
Uh,
doing a URL session network request?
no, this is literally just an API request. So
Normal API request.
yeah, this is a normal API request, but
Okay.
then OpenAI has like really large servers on like NVIDIA they will run the input output for the LLM. So they do it on their own thing and they return a string. Yeah.
Okay. Thank you.
But this is just a normal API request. It's nothing special.
Okay. Thank you.
I
Yeah,
think Jyoti.
hi, Natasha. So
Hello.
I'm new to you AI, so I just wanted to understand like this. We have created this poem writing application, right? But there
Mm-hmm.
are certain sensitive topics or restricted questions that we ask to ChatGPT, right? That they do not answer to, or maybe that are restricted or sensitive that they cannot reply to. So can we use like system prompts to train the model that they should not reply to it, or how
Mm-hmm.
does that work?
Yeah, exactly. So you can even write like if the poem topic is like inappropriate, reply back with sorry, this topic is inappropriate. Try another topic. So already like ChatGPT and Claude, they will already be censored in that way. So
Right,
and Google Gemini, if you're interested for sensitivity, Google Gemini gives you back a whole like sensitivity score, like safety object.
right,
So here I just show you the reply is like I just kind of take out the message of the assistant, but as you can see, like the response is much bigger from the model. So they also give you like usage data, how many tokens were used. And one of the things that Gemini gives you back is like it's just a JSON object that you get back. So Gemini gives you back like a whole safety array or a dictionary that you can even use. So you can, by default, in this case, the assistant will reply it's inappropriate if it's not aligned with OpenAI's model. But if you want it to be more safe, you can use the Gemini model, and we'll go into other techniques. I'm not going to use it here, but it's called function calling, where you can also do kind of another call to assess the appropriateness of this poem. So instead of like write a poem about this, I will say, judge safety of topic, right? And then I will have like a system prompt that will say, you are judging if this is a safe topic. And here you will specify what does it mean if something is unsafe, because that could mean different things to you than to the model. So this is where Claude could be good, because it can say example of unsafe topics. And then, and then your user message will be, is this topic safe? And you would get back a reply. We'll go over in the next example, but you can get back a JSON output where you can specify like a true, false, and a reason for why it's rejected. Then if like the model returns that this topic is not safe, then you can show to the user why it was rejected, or like why it's not safe. And also if you have other logic, like if it's not safe topic, then you maybe after 3 attempts, you kick the user out of your app and you say you can't use it because it's expensive to run this LLM calls. Does that make sense?
Got it. Got it. Thank you. That was helpful. Thank you so much.
Great. Anyone else have questions?
Yeah, just like we can specify what JSON output we want, right? Can you share more on this?
Can you say that again?
Yeah, you specified that we can customize the JSON output structure.
Yeah,
Is
I'll
that
go.
correct?
This is a future. Yes, exactly. That'll be the next thing I'll be talking about. Yes.
Sure, thanks.
Great. Yeah, so now the next topic is structured outputs. So again, as you saw, sometimes we just want like that text, like give me a poem, but most of the time you want like a JSON response. You want to parse the user's information or some sort of information and get structured data. So this is called either JSON mode or structured outputs in function calling. So for this example, I'm gonna build like a computer scientist app. It's just very simple. It will take Wikipedia information about a computer scientist, and it's gonna extract like date of birth, nationality, education, and notable achievements. So this is something good for like if someone is reading a book, or maybe you have a journaling app where the user writes their thoughts for the day, but you want to extract like what was the mood of the day, what are the key points. Like if you have a meeting also, it's nice, you can have the whole transcript of the meeting, or you can have like a earning call, and you want like what are the key facts, give me 5 key facts from this call, give me a summary of this call, give me like date of this call. So you upload some large chunk of information, you give the model that information, and it will give back to you like extract out like the components that you want. I already have this. So this is how it looks like. I clicked on Margaret Hamilton, and this is the Wikipedia information that I got from the Wikipedia API. And then it extracted this like date of birth, nationality, education, and notable achievements. So it's as simple as this. And you can think of the Wikipedia backend could be your backend, whatever company you're working with, or your journal entries, your books, whatever data you're working in could be replaced for the Wikipedia API. So how do we do that? So one thing is you first want to have like a codable object of like once the JSON response comes back, what does it look like? So I have a computer scientist detail object, and I want like date of birth, notable achievement, nationality, and education. So one thing to note is that the LLMs are trained in internet data. And when you think of coding data that is available on GitHub, a lot of it is in Python or JavaScript or like web based, and there's very little Swift training data. So that is why, if you're using AI for writing Swift code, it'll be like very bad code because there just isn't that much data for Swift code compared to like Python. So for my Sanskrit app that I'm building, I'm literally writing like daily Python scripts to scrape data, and using Python with LLMs is like so easy. It just gives me a great script like every time, versus with Swift, it's not great. So when you're working with kind of this JSON objects, you have to think, and functions, you have to think what is available, what is the model trained on? And it's trained on internet data. So even though in Swift code we want, date of birth in Swifty way, in model data we need to have the snake case like this. So again, this is tricks that once you understand how LLMs work, then you're able to work with them and get better outputs. So don't get stuck with like the magic of it. It's literally like trained on what's on the internet, and most of the time it's going to be JSON code. So you have to match it. So this is the object that will be decoded. And when I have kind of more complicated prompts, I have like a prompt manager, because then I can easily see what are my prompts and take it away from my code. So what you do is you provide the JSON schema of the object you want. So this is my object that I want the API to return back. And it's just this output. So be very careful with your descriptions, because remember, AI is very good with words. So the more clear you are what you want, what format you want, the better. So here I just specify I want these properties: date of birth, notable achievement, nationality, and education. And then you could say, which ones are required. So that's it. It's kind of annoying. What I do now, I used to like type these out myself. But what I do, I just take the example they have on AI proxy, and I will put it into Claude, and then I will kind of send my object and say, generate this for me, because it's kind of annoying to type these. Yeah. But this is all that is done to create the schema, the JSON object that you want back. Does that make sense to everyone? Anyone have questions?
This can be used only inside functions or can be completion.
Yeah, I'll talk about function calling next, but in this case, we're just looking at JSON outputs that we want. This is for structured data. So in structured data, you give one piece of text and you're like, extract this information for me. Or you can have it give you key points or summary. So you want to like, here's my chunk of data, give me back this information. That's it. It's only a one-time call. Okay. So now we look at the system prompt. And again, I want to say, you are a specialized information extraction assistant. So you want to, like, this is what you wanted to do. And then I say, your task is to analyze Wikipedia articles about computer scientists and extract specific biographical details in a structured format. So I think I use I use OpenAI, but you can also use Gemini API for this, the Google API. And I found like you have to say the sentence, like give me back information in a structured format, because sometimes it doesn't work as well. So when provided with the Wikipedia article, I want to extract and return only this information, nothing else. And here I also specify what I want. And then here you have guidelines. So as Jyoti mentioned, you if you want safety or whatever you want, you give your AI guidelines. Like if something isn't available, mark it not specified in article. In date of birth, I want this format. So you want those guidelines, what it should do in every situation. If there's multiple nationalities, list these as commas. So what happens is when you run this app multiple times, you'll run into weird issues. So this is where you keep adding the guidelines as a feedback. Then you add, okay, don't do this, do this. In this case, do this. And it's nice also to give an example output, like to show this is what I want. Then it's more, we talked about fine tuning. So this is fine tuning would mean giving many examples of input and output, like maybe hundreds of examples. But without fine tuning, you can just give what you're expecting, and then you get back good results without having to fine tune the whole thing. So this is the system prompt and the user prompt. In the user prompt, I'm going to get the Wikipedia page content, and I'm saying, please analyze the Wikipedia article and then extract the information. So does this make sense to everyone? Does anyone have questions?
Hey, I have a question actually here.
Mm-hmm.
So, if we are, I mean, building a prompt, can
Mm-hmm.
we in their API documentation or anywhere, can we test our prompt there itself and fine tune our prompt whether it is giving the required result, or as per our needs we can modify rather than every time calling from our app before, I mean, writing the prompt inside our app, but basically in their website only. Is there anything? Just
Yeah.
want to know.
So like OpenAI has many of them have playgrounds. So Google has AI Studio. So Google AI Studio, I believe. Yeah. So this is most places like Together AI also has AI Playground something. So each of these do have a playground where you can run it you can basically like select which model you like, system, create new prompt. So just each one is a little bit different, but this is the Google AI Studio where you say, here's system instructions, and you paste here, you use which model you like, and here they give you how much pricing there is. I don't know where. It's OpenAI. Yeah, so the answer is yes.
Okay, thanks.
I have one
Yes.
quick question. Is it possible that instead of providing the content of any Wikipedia page or anything, instead of that, can we just provide the URL link and the model itself read the content from that?
Yeah, so this is why I showed that video in the beginning of how large language models work, because we have this like magical idea of them that they will like go on the web and do all these things for you, but they do not do that. They literally will take a language, like document input and give you an output of like next likely words. So this is all they do. They do not like go to the web and scrape it. Does that make
I
sense?
have मतलब
Got it.
मैं एक
Got it.
इवेंट में साइन अप करती तो हूँ जॉर्ज
Uh, yeah, sorry, I speak a little bit Hindi, but not that well.
Uh, no. I think someone get unmuted and speak something, but yeah, I got my answer. Thank you.
Okay. But I'll show you later techniques you can use for what you're saying. But the reason I'm saying this is because always think, what is the LLM? What is it? What is it? You know, I want you to go beyond the magical goggles of what the marketing has done. I want you to think, you know, it takes in words, it gives back some other words that come next in line. That's it.
Sure.
Yeah. So this is my prompt manager where I will define my scientist like schema that I want and user prompt. And now when I'm doing the API call, again, I have my OpenAI service. Right now it's unprotected for demo purposes. So just like before, I create a chat completion request. I specify my model. I give my system message and I give my user message that will include the Wikipedia article. And then this is all you have to do to get the JSON schema. I just specify my JSON response format is JSON schema. And this is, computer scientist data and description, structured biographical data extracted from computer scientist Wikipedia article. And I give my schema object, and you can say like strict or in this case, actually want false, but I somehow copy paste it. But strict means, do you need do you need it to match exactly to your schema? So in this case, it's actually optional for me for each object, but you can play around with it. The strict parameter is sort of new and a little bit weird. But you can see if you need exact like specification, then you say strict. So that's it. So this is your response, or this is your request actually, but yeah, this is your request, and you get back a string. So remember, the large language model always gives back words like a string. But in this case, because we specify JSON schema, it gives back a JSON string. So it's still going to be a string if you print it out, but you have to encode, like say that this is a JSON data because it's from string. And then you decode the string into your object. And then you can return back the actual object and use it in your Swift app. So does this make sense to everyone?
Yes.
Okay, awesome. Yeah, so that's all it takes to get like that JSON data from an LLM. So one other thing that you will hear, so like kind of the next topic is retrieval augmented generation. So the LLM was trained on data from the internet and it has a cutoff date. It was trained on data from internet from 2023, from 2 years ago, maybe 1 year ago. As soon as it's trained, it's lost all the context of news. So for example, like the LLM will not know that the current president of the United States is Trump because the LLM was trained before the election. So if you go follow on Twitter, you'll see, you ask the LLM who's the president of the United States, and it's gonna say Joe Biden or it's gonna say like other person. So this is a problem. So how do you solve this problem? It's like called retrieval augmented generation. So this is one of these terms that you'll hear and like sound very fancy in academia, and this is why I'm bringing it here. But basically, what you want is you want to provide the LLM with the data. to make more accurate responses. Because even if it was trained on that specific Wikipedia page, it's kind of like this long memory. You want to give it context and you want to give it whatever information is relevant to make the response. So this is augmentation. So retrieval part is how do you retrieve relevant information from your own personal data sources and give it to the LLM. Augment means to add. So you retrieve your information and you augment the LLM with that information. Then the LLM will generate the response. So that's what this kind of topic means. And you already understand how to use it. In this computer scientist example, we retrieved the Wikipedia information about that computer scientist, and we added it, we augmented it to the response, to the prompt, and gave it to the LLM. So it's as simple as that. You have to think what is relevant information that the LLM needs to make the response. And this is how news works. So, you can get a news API. You can first figure out how do I search that news API for relevant information, and you can add it to the prompt, and the LLM will work well to give modern information, even though it was not trained on that information. So you might have heard of Perplexity AI. It's one company founded by an engineer, and this is basically what he does. He applies LLMs to kind of search results to get more recent information. So to demonstrate this, so this is within our famous computer scientist app. There's one scientist called Ian Jackson who doesn't have that much Wikipedia information, just 1 or 2 paragraphs. So as you can see in the Wikipedia article, there's no date of birth and there's no nationality. And I Googled also this person, and pretty much besides the Wikipedia page and a little bit information about his work, there wasn't much information. So in this case, this is the correct output. The API does not give us a date of birth because it didn't find it in our context of Wikipedia article. So to test this out, I went to ChatGPT and I said, provide the following details for computer scientist Ian Jackson, date of birth, nationality, education. And guess what? ChatGPT gave me a date of birth. I then reran the prompt. It gave me a different date of birth. I then reran the prompt and it gave me another date of birth. So again, I told you about LLMs hallucinating. So this is the problem. The LLM will actually sound confident. And this is the problem. If you're an expert in the field, like if you're a Swift developer and you ask it for Swift code, you're going to know very fast that this is hallucinated input. But if you're like not a history of computer science expert, then this answer looks realistic. You're not going to be able to tell that only date of birth is hallucinated. And it also says he's a British computer scientist, and I haven't found that nationality was British. I did see that he went to University of Cambridge, but I don't know maybe where he was born. That's not available. So even the British part is hallucinated, but it's an educated guess. Because maybe it read a lot of documents where a British person went to University of Cambridge, so it assumes British. So this is where this augmenting technique is very important to make sure you give accurate information and not hallucinated information, and you get the most recent information. So one way to augment is also doing web search, which you mentioned correctly. So Bing, this is again augmentation example from using Bing chat. So in this case, the Colombia president was new. So first you will perform a web search, get back articles that are relevant for this search. Then you will basically paste into the prompt all the results. And then the LLM will use that information to extract the relevant data. Does that make sense to everyone?
Yes.
Yeah,
Yes.
thank you. So how can you do that in your own code? So Gemini, Google's AI model, they have a tool called Google Search Retrieval, and in Gemini 2, it's called just Google Search. So you literally, it will decide when to do a Google search, get the articles, and stitch them for you. So this is like super good benefit of using the Gemini AI, which is really good. So in this example, what is the price of Google stock today? The LLM can hallucinate any price, but it doesn't even know what is today. So Google will go ahead, it will Google what is the price of Google stock today. It will augment it for the LLM and it will return back an accurate result. So if you do need that modern news type information, this is like very beneficial. I'm making one app as a demo for my next workshop. It's for recommending movies. And it's very nice for like movie recommendations because if you don't use Google search, it will not recommend the most recent movies that were released like in the last year. So even like something like that, where you think, okay, like movies, it should be trained on a lot of movies. It's not trained on most recent movies. I also can do requests like give me movies, like Bollywood movies that are on Netflix or on Amazon Prime. Because why? The Google will first Google the question, then it will give it to the LLM, and the LLM will create back a really nice response to the user. Does that make sense to everyone?
Yes.
Okay, awesome. So now we'll go into function calling. So we went to structured outputs.
Hello.
But yes.
I have one question.
Mhm.
When you were discussing about like Gemini, Google, I mean web search, like last
Mhm.
slide, um, you said the options will be augmented. The web search
Yes.
will be augmented for the models. What do you mean by the
Yes.
augmentation of that thing? Yeah, this.
So it's literally like copied and pasted, like we did with the Wikipedia article. I literally copied and pasted the Wikipedia article into my prompt. So in the same way, Google will copy and paste whatever it searched into the prompt. That's it. So again, this is going back. What are LLMs? They intake text, they output text. So augmenting just means you add more information to the prompt.
Okay, thank you.
Yes. So now we'll go to the next level. So one problem is yeah. So one thing is in structured outputs, you just give one piece of text and you get back, some kind of structured information about that text. But what usually happens is if you're interacting with the user, you might not have all the information in the same time. Like you might have to, like, let's say you're making an book a restaurant app. So the user wants to interact with your app in natural language. So when a person uses your app to book a restaurant, they're gonna say, book a restaurant for tomorrow at 3 p.m. But this doesn't give you all the information you need to book a restaurant. Which restaurant? Give me the name of the restaurant. How many people is it for? So function calling allows this process where the LLM will follow one, it will parse the user input, natural language input into structured data, but it will also have a conversation and follow up with the user until it will collect all the data necessary. At which point, once you get back all the information, you can call a function to book a restaurant. So it's a little bit confusing because it's called function calling, but the AI never calls the function. It only parses the natural language to give you everything you need in your app to call the function. And once you call the function, you can follow up with the LLM and give results or show something to the user. Yeah. So what is function calling? Again, the LLM doesn't call a function, but it imagines a function, and it imagines like the parameters the function needs. And then it will continue a natural language conversation with the user until it gets all the information for you. And then you can finish the goal that you had with that function. And this allows the LLM, the large language model, to interact with a kind of external tools, API, data sources in a structured way. Because again, we're switching over from these like hard-coded screens where the user selects exactly which restaurant, what time, which date, to natural interfaces, natural languages. So this LLM or this function calling is that middleman where the user can interact with the LLM with natural language, and you get back structured information that you can then use in your app to do any actions. So how does it work? So first you will have a function definition. So in my app, I will have, a book restaurant function that has name, date, number of guests, and the time of the reservation. So user interaction. So using natural language, the user will say, book a table for 2 at La Trattoria this Friday at 7 p.m. So now LLM will interpret the user query and extract the parameters that we need for our book restaurant function in our app. Then, once we have all the parameters, the function is called. So in our case, you might send a message to the server and then book the restaurant. Then you come back and say, the restaurant is booked. And then the LLM can provide a final user-friendly answer, like confirmed your result is there. Your booking is confirmed. But what happens if you make your API call and then that time is not available, for example? You can give back that this time is not available to the LLM, and the LLM will continue prompting the user until it gets the new time. So this is like super powerful for this language-based chat or audio-based interfaces for Swift apps. And this is the kind of visual version of this from now they changed it, but this was OpenAI's function calling documentation. But what I want you to take away from this is that there's this interplay between your code and the LLM, right? Like you have the user answer something, you give it to the LLM will process it, that might reply back, you show back the reply, it gives back. So this is where like many people are scared, my like AI will replace me, but as you can see, like there's a lot of code needed to interface with the LLM. It's not just LLM doing everything for you. LLM is good at parsing natural language, but you have to still build the logic in your application of how to display it, how to interface with it, which functions to call, actually do actions in the real world, not in like an imaginary LLM world. And I'll go through an example in the next section. First, this is an overview, then I'll show you code for function calling a little bit later. So again, we started out with, understanding LLMs, that they're large auto-completion machines where they will take some text and they will predict what is the next word. So that in itself is powerful. It's really cool, but it's not powerful enough. So there needs to be, more help for the LLM to do its job and to become useful for us. So this is called the augmented LLM, right? You have the LLM, but you need 3 other parts to make it powerful. So one part is retrieval. So we talked about how you need to give the LLM relevant information from the user to make a good response. Next is tools. So we talked about Google search as a tool. right, to get the modern information. We'll talk about function calling. So one example is you can give it a calculator tool. So you don't want the LLM to do math, but you can, if it is a math question that the user provides, you can have the LLM provide kind of Swift code maybe, or even some kind of structured version of the math question. And then you can have a math function that will calculate that information, like for finances. And then finally, as someone mentioned, LLM does not have memory. It's like an in-out model. So it will only take one input and it gives an output. It will not remember your 10 previous conversations or messages. So your app will be responsible for remembering the conversation, for keeping track of the conversation using Swift data or some server, Supabase, whatever you're using as a backend. And then it is your responsibility, kind of going back for retrieval, to figure out which parts to give to are relevant for the LLMs and which are not. So this is kind of the ecosystem and the building block. Does anyone have questions about this? And I'll go into code in some time. But does anyone have questions about this concepts?
Just LLM is a in-out model. So every time we send a new query, should we need to send the previous questions as well, questions and answers as well to get the
Exactly.
best result?
Yes. Exactly. So you need to give every single user an assistant message in that conversation. And the reason is, so imagine a book a restaurant conversation. So first the user says like, I want to book a restaurant for tomorrow. Then maybe later they say, actually book it for next week. So the LLM has to have the full conversation to parse accurately the actual data. You cannot just give the previous words. You have to give the full conversation. Yes,
Okay, and will it
exactly.
affect the
Yes.
pricing, right? It will
What is
affect
it?
it will affect the pricing when we send all the
Exactly.
conversations. Okay.
Yes. But I would like for language models, it's becoming cheaper and cheaper. So that's why I showed you like Together AI, Grok, but also Google Gemini is like very, very cheap now. It's essentially like free. So these pricings are going down because everyone needs large context windows. So everyone has to do this. So this is becoming cheaper. The providers are caching kind of your API call for some time. So it's becoming cheaper and cheaper to do that. But this is the workflow that you need, yes.
Okay, thanks. And I do have another questions. Is there any best way for retrieval? Actually, I have a document applications where user can write a long document, a long text, you know,
Mhm.
from where I user can edit that document using the AI, or user can ask any questions to AI from for relevant to that document. So is there any best way for retrieval so that if I can identify that the user is actually want to edit something in the documents, or he wants answer from the documents, because sometimes it becomes difficult to differentiate user's query. He wants edit, or he wants uh, answers from the document itself. I guess these things only can be done from the LLM can
Yes, exactly.
give us the idea that user wants edit or user wants
Exactly. Yes.
okay. And because I tried retrieval using the vector data, and tried to get the relevant data from the entire documents, but I didn't find it that helpful, because the data I am expecting to get from the vector search is not the accurate data.
Yes.
So is there any other ways that I don't know that I can get the proper retrieval of the document from the all the context I have.
Yeah, so you already mentioned vector search, but now Google Gemini has a very long context window. So even if you have a very, very large document, you can still upload the documents to Google Gemini and then just let the user talk directly to the Gemini model.
Okay.
Yeah,
Actually, we are also providing the support to the local model, and the local models are not that much efficient to process all the document data, and that's why we need a
yes.
retrieval of the document. So I just wonder if there is a
Um,
way to.
yeah, you can look on my blog. So I wrote about this. So in this is data. Yeah. I have a blog post on this, but basically what you can do is you can chunk the document into smaller parts. And again, I'm using Google Gemini model. For local models, it might be more difficult, but there's also chunking. You can break down the document using sorry, chunk. Yeah. So
Yeah.
you can use natural language like speech recognition framework in Apple, the NLP framework, natural language processing. So first you can break the document into smaller parts,
Okay.
and then you will they say you can Google this. It's called chain of agents. But basically, you just send each smaller chunk to the LLM with the query, and then you get the relevant information from each chunk. And then you will have one manager agent, like one manager LLM that will get all the summaries from each chunk, and then kind of process that into one response.
Okay, basically it will
Yeah,
basically for this, I will have to create a multiple request to send a multiple chunk, right?
exactly. And then
And
you want one kind of manager request where you will kind of process, once you get back all the responses from every chunk, then you want one LLM call to process every single chunk data and then give back the answer.
okay, I'm sorry, I just want to clear this. Uh, for example, I have sent the chunk of data in a multiple request. I received the response, multiple
Hmm.
response from that multiple chunks, and
Yes,
then using that response, I will have to request again,
yes,
again to the local model for the exact
yes.
response, right?
Yeah, you give back all like the manager model will take in every response for every chunk. And
Okay.
then it will give back, it will summarize the full answer.
Okay. Then there are again the possibility that it exceeds the token limits if I send all the response in one request.
No, the response will be short. So like for example, in this app, like I uploaded my resume, but this is a smaller like a PDF that I was testing, but I uploaded my resume and then I got chunked my resume into like where I went to college, my work history, my name, my email. Then I ask a question, where did the candidate go to college? So then each chunk, it says this does not contain any information about where she went to college. So your chunk summary will be very small. It's not like very big because it's just answering the query that the user has. So this one doesn't have the information, but then this one it shows where I attended college. So now the manager model will only have this information. It won't have the chunk information. It will have the chunk output information that it's
Okay.
processing. Does that make sense?
Yeah, thank you so much.
Okay, great. Yes. Okay. So now that we have the understanding of the LLM and how to work with them in multiple ways, we're going to talk about agents. So you might have heard the buzz, like 2025 is the year of agents. So what is an agent? Ideally, like I would say an agent is a software system that uses artificial intelligence to perform tasks autonomously on their own, often with minimal human interaction to achieve specific goals. So you might think of like kind of like a more fancy agent where I had one friend and he works in editing, and he was saying, I want to upload my PDF that I need to edit, and I want to upload another PDF with all the like brand guidelines or all the guidelines for editing that is given to me by the company. And then I want the model to go on its own and give me back the result without me doing anything. So, like, this is what an AI agent is ideally. But as you saw, large language models are not good enough for that because, they're not good at like spelling mistakes, for example. Because like if you were to say find spelling mistakes, like you can just use like find and replace will be more effective. So because of how they work and how they're based on tokens or partial words, they're not going to be able to like separate every letter and find the mistake. So there's going to be a lot of issues if he does like a fully autonomous system because LLMs are not good enough for that yet. It's fun, like it's fun to build, but I personally don't trust, you might have seen also like give me text to website. So you just give text and the LLM builds the whole website. Yeah, it does that, but the code is not going to be good. It's not going to be something you could deploy. It's just like a fun activity, yes, but it's not like an actual website that you can debug even because the code is so bad. You might have heard of Devin, like the software engineer, where it will go into PRs and try to change it. So I'm not a fan of this definition of agents because I don't think the LLMs are good enough. So I have my own, and this is not what people have been using the term for. Some of them have, but I think of an agent as like a workflow that orchestrates interactions between large language model, user input, and application logic to accomplish tasks. So there is some goal in mind where you want to accomplish a task. And you want user input. You want the user at every step to say, yes, this is right. This is the good direction. This is bad direction. Or it makes some choices. Choose from, like for a recipe app, I'm building that now. Like you want the user to say, here's all the things in my fridge. Make a recipe. So there's apps that do that. But the problem is, if it gives a recipe I don't like. So I want user input for the user to say, yes, I like this recipe, or no, make something else. So I think of it as like a multi-dimensional workflow between all these things where your application logic will do function calling and tools. There's going to be your language model, which will interact with the user. And also your user will have an input, and the goal is to accomplish a task. So to give an example, I'm gonna show you a weather chat, like a single agent workflow demo that does this. And the reason I'm doing weather is because whenever you read about agents, they will always have a weather example. But if you think about weather apps, I think it's an interesting use case. For weather apps, you open it and it'll say, this is the temperature, this is the humidity, and this is the rain percentage. But with LLMs, you can now do more interesting weather apps. Like, is it a good day for stargazing tonight? So the LLM can figure out that, today in the night, it's not going to be clear. So it's not a good day for sky gazing or stargazing. And then I can say, do I need to bring a jacket? Or you can say, I'm traveling to London next week. What should I pack for my clothes? So this is like really, really cool. It takes weather to a whole new level. It's not just the simple, like, is it raining? What is the weather? It gives you actual actionable information to the user in natural language about any question they have about the weather. So this is a really cool app, and I'll show you, the workflow, how it works first. So we talked about the building blocks of these augmented LLMs. So first is the retrieval. So first we have to say, what is the relevant information for the LLM? And in this case, the LLM needs to know where is the user located. So the application using core location will give the location of the user to the LLM. Because if the user asks, should I bring an umbrella tonight? It doesn't know where is the user located. So for weather, that is very important. If they say I'm traveling to London, then this is fine because the LLM can figure out this is for London. But initial part is we need to give it that relevant information, which is the user's location. Then I give the LLM tools or functions that it can call. One tool is get weather. So iOS has a WeatherKit API that can provide like current weather, historical weather, hour by hour weather. It's very nice. So this is where, I don't think AI will replace me because I still have to code this WeatherKit API function that the LLM has to interact with. And remember, like LLM does not have access to the weather. Then I have a function to convert temperature because I don't trust LLM to do math ever. But for Celsius Fahrenheit, it can convert probably like normal degrees. But maybe the user asks something crazy, then it's not going to be able to convert it. Does anyone have a question? Sagar HP? Yeah, thank you. So you can think of other examples. I put like some ideas here, but let's say you want, you can, again, this is the functions I have so far, but you can think, email me a shopping list based on what I need to pack for my trip based on weather. So you can have a function for email. So maybe the user says, email me like a shopping list. Then you can have a function in your app that will send an email. You can use a calendar to schedule your picnic. So maybe like based on the weather, the user wants to schedule something, then you can have a function that will integrate with the calendar. So this is where like the power of iOS really shines, and it's not possible on the web. So that's why I encourage all of you to start building with AI because iOS is the best top. Yes, yes. 1 second, sorry. Sorry about that. Yes, top floor. And yes, sorry about that. Yes. So next, you can automatically trigger notifications for like extreme weather conditions. So again, with iOS, we have so many building blocks and we have so much opportunity to work with LLMs. You can update calendar events with weather details. So this is pretty cool. Like add a reminder to bring an umbrella if it's raining on Monday. And we have HomeKit devices. So imagine you can like update, like if it's raining, then you close windows and adjust thermostats. If it's cold, then your HomeKit will make it warmer. So like really, really think about this because I feel like this gives so many opportunities for us as iOS developers, but unfortunately the Swift community has not been as big into LLMs. So these are the tools. And then memory. So again, the application will keep the full chat history, and then it will pass it back to the LLM every time to continue the conversation. And yeah, this is the diagram of how it works. So the user first asks about the weather, right? Like, what is the weather today, or what should I bring today? So that in the application layer, you will have logic that will append the message to a chat history and get the user's location. Then you will send all the chat messages and the location to the LLM, and the LLM is going to think, is the weather data needed? Because if I'm saying, should I bring an umbrella tonight? Then the LLM has to know what is the hourly forecast for tonight in Rishikesh. So if it does need the weather data, it's going to go back to my app. It's going to give me all the function parameters that I need to call the get weather function. And then once I get the results from my function, I'm going to append the function results back to the user message. And I'm not going to show to the user message the actual raw weather data, but I'll send it back to the LLM. And now the LLM has the weather, and it will send a follow-up message to the user, to the app that I will show to the user. And maybe the user asks, but what is the temperature in Celsius? Then it will do the same process to call convert temperature function. And then it will append the result back as a user message and send it back to the LLM. Does someone have a question? And I'll
How
show
does
this
it
in
find
code
out?
as well. Yes, go ahead.
How does it find out that the weather data is needed or not? Like, how does it think about that?
Yeah, so let's say, like, it thinks like you would. So let's say someone asks you, do I need an umbrella today? So what will you do? You will go like to Google weather. You'll Google like, what is the weather tonight? And then it will say the weather is cloudy, and there's like 40% chance of rain. Then you know I need an umbrella. So the LLM will autonomously decide this itself. And you also specify when to call the function, but basically the LLM will understand that I need weather data to answer this question. Like if the user asks, can you convert this temperature to Celsius? It's going to understand that it needs that convert temperature function. So this is
So
the magic. Yeah, this is the magic of it.
that part is uh, like the agentic part of this.
Exactly. Yes.
Okay, okay.
Yeah, the LLM decides that it needs to call that function. Does anyone else have a question? Okay,
Yeah.
so now we
Hi,
can
Natasha.
look into the code. Yep.
Hi, Natasha.
Yes.
I'm just having a question with the first block. Like user have asked for weather. So
Mm-hmm.
how that LLM will decide to get a location means first block of
Right.
request.
So I as an app in my system prompt, I will give the user's location myself. So this is on the app level, not the LLM level.
Okay, okay.
So this is an example of retrieval, right? I need to give the LLM relevant information. So I know that I have to imagine. So this is where like working with LLMs is more difficult because when you work with a traditional API, you kind of like have a more preset case. You might have a form, right, where you say where are you located, what is
Uh-huh.
your question? But with LLMs, you have natural languages. So if you have a product manager that has user stories, if you heard of this user experience concept, you have to imagine how will this app work, right? So I'm imagining user asks about weather. Like if it was me, I would ask, what is the weather tonight? I will not say like what is the weather tonight in Rishikesh. I might say that, but the user, when interacting with an app, understands that like the app should know my location because they've used many iOS apps. And also the app will ask like permission to use location. And in the case that the user doesn't give permission, then you cannot give the location to the LLM, but the LLM will then ask a follow-up question to get the location because it's needed for the weather data. So this is just, you have to imagine what is all the information the app needs, the LLM needs, and then you retrieve it and give it. So this is just using core location framework.
Just correct me. So means sometimes it happens that requests are not given for a location or suppose
Exactly.
at that time LLM will decide to ask for location or that
Yes,
location.
exactly. Yeah, and I'll show you how, but basically you saw the structured output. So to get the weather data, I'm gonna tell it you need location for the weather to get the weather data. So if the user, in the case that the user gives the current location, the LLM will not ask the user where is your location. And especially if the question is just like, what is the weather tonight? But if the user doesn't give the location and says, what is the weather tonight? Then the LLM will say, where are you located? So this is where the LLM will do the magic part for you.
Yeah.
So now, yeah, I'll dive into the code and hopefully it'll be more clear, but I wanted to kind of give that conceptual overview because it's a bit, intense. Yeah. So here I have a location manager, and this is using, again, core location. And I'm just showing you, like, you can get this code. This is just basic Swift code that you might work with. Yeah, so here I have like logic, because imagine also one problem is the person, when speaking in natural language, they're gonna say, what is the weather in London next week? So they're not gonna give like latitude and longitude, which is what is needed for the weather API. So I have logic in my own app that's using like location services that will like figure out like what is the address, what is the location, what is the location's like latitude, longitude. So this is just all iOS based app logic. So this is where I'm saying, AI will not replace you because you have to code a lot of this logic for the LLM.
Right.
And then, yes, and then I'm using WeatherKit API to get the location. And here this is the function that the API, the LLM has access to. And it will get weather. I want location, and CL location is basically like latitude, longitude. So I do some work. I have some logic in the app to convert city name using core location to latitude and longitude.
Okay.
And then I want forecast type. So the WeatherKit API means current, because maybe like the user asks, what is the weather right now? Then you want current location. Maybe the user is asking, what is the weather tonight? Then you want hourly location. What is the weather in 2 days when I'm hosting my picnic? Then daily, it even gives minute by minute forecast. And then it also gives you historical forecast. So one example is I typed in a prompt that said, my friend is coming to visit me in Rishikesh in October. What should she pack? So it will then trigger a historical search where it will look for location like weather from last October, and then it will kind of use that data to see what the weather is like to tell my friend what to pack. So this is pretty cool. So, it's pretty complicated get weather function here, but we give all of these as, I'll show you as a JSON schema as parameters for the LLM to use. And then I have another function to convert from Fahrenheit to Celsius. So I just have this is all it takes. It's just a math function. So it doesn't need like specifically to be in the weather service, but this is just a quick example. Convert from this value from this, and I have text. So
What
what's
kind of,
interesting?
can I ask
Yes.
what
Yeah.
kind of response do you get from the weather API? Like, I was wondering, is it like integers or some text?
Yeah, so I'll show you that next. So here's the this is just like a bigger function where I call kind of current weather hourly forecast. And you can look at the WWDC video for the WeatherKit API. So I'm not going to go too much into detail because this is just Swift code and you can easily research this. So I'm getting the current weather, and this is what you get, like what it feels like, what is the actual temperature in the unit I specified, what is actually feeling like, visibility, and you can do kilometers or miles, in wind speed and location string. Okay, so this one is I just have a function that will take a CL location and it will get the address. So what's interesting here is normally you would want to kind of give back and work with objects like current weather object in your app. But since we're working with LLMs, this is where the change happens. Instead of returning back an object, I'm gonna return this. I'm gonna give all the information to the LLM. So this is where it gets interesting. You don't want to be, the LLM cannot work with your object. It can only work with words. So you have to be careful. Like this is my current weather information that I give the LLM. Does this make sense? Was this your question?
Yes, yes.
And this is why I convert my location from CL location, which has latitude and longitude, to string, because the LLM like it might know like longitude, latitude, like where things are because it's a lot of online data, but I don't want it to like use that for the user. I want it to be in natural language. So I say, weather conditions for Rishikesh instead of 48.555 comma this like latitude longitude strings. So the same is the case for all the other forecasts. I'm just using the weather API and I'm returning like a string every time. And for hourly forecast, it's a bigger string. It's 24 hours of forecast data. So it's going to be like, at this time, this, at this time, this. So this is going to be much more tokens than the like one-off current weather. And then we do the same daily forecast where you have to say this date, this is the weather. This date, this is the weather. And then minute by minute forecast we have. And this has participation, chance of rain, and intensity. And then historical forecast, I ran into a little bit of a problem. It takes in start and end date, but when I tested it, one thing is it only has historical data from August 1st, 2021. But the other thing is it wants only 9 days. So what happened was I tried this prompt that said, my friend is visiting for 2 weeks. What should she bring? But it doesn't support daily weather or historical forecasts for more than 10 days. So what I do is I'm checking, but the LLM doesn't know this. So it gives me like what is the start date and end date. But in my code, I kind of normalize it and have, you start date plus 9 days if days in between is 9, but otherwise it can do the end date that was requested. So those are the type of weird things that come up in natural language that might not fit to your API. So you have to normalize the data and fix it. And then I return back, either no historical information is available for this data, but if it is available, then add to my forecast. And I think Yeah, now it doesn't have an all function. A second. I also have an option that like will take everything, every single forecast, and then get back, everything separated. So maybe like that could also be part of retrieval. So if you wanted to, you can potentially give that upfront. But the problem is, uh, one, you're assuming the user is asking about their location, but they could be asking, what is the weather tomorrow in London? Because that's where I'm traveling. So you don't want to assume that you just dump all the location for one place for the current location. So does anyone have questions about this part? Just the WeatherKit API basics? Okay. So now we go
Natasha,
like, yep, yes.
just one thing I need to ask you. I don't want to go deep into this, but what I am trying to ask you is, what kind of uh, scenarios you have faced where LLM is needed our input from core side, or you need to give such, as in you, it is depends on us from means application side to get location. So what kind of scenarios you have faced with it, and then can you list out that scenarios where LLM is needed or input the most, or such scenarios where we will have to take care of? I am not a bit familiar with the LLM much. I have just started, so asking you. Did you
Um,
understand my question?
you're a little bit quiet.
Okay,
But this
so
is just one example, but there's just many scenarios where you would need basically you have to think. This is why in the beginning I mentioned this is what an LLM does, right? An LLM
okay,
takes text input and it gives text output. It cannot do math. It may sometimes be right with math, it may not be right with math. So you have to think, if this is the LLM which takes input and gives the output, and it's not good at math, it's not good at counting words, like how many letters in a word, it's not good at certain things, but it cannot access my database. If I have a journaling app, I need to give it my journal information. So this is why I'm creating the framework for you. And then you have to think, when should you call the function? When should you call the app? When should you use SDKs from iOS? When should you call your own database? So you have to make those decisions. It depends on exactly what you're building.
okay, gotcha.
Yeah, so this is Weather Agent is just one example that combines everything that I've mentioned. But you have to, again, like go back here, the augmented LLM. This is the building blocks. How do you work with these building blocks? So all of this is new for everyone, not just you. Even in the Python community, so people are building tools. Uh, so you have to decide, LLM is only taking text and putting out the next probable text. What do I need to do on the application? What does the user have to do? You have to make those decisions. I'm just giving you the tools.
Okay, okay, gotcha. Thank you.
Great. So I mentioned about function calling. So just like in structured outputs, our weather function has few things it needs. And again, when you look at the function get weather function, it needs location, forecast type, and a temperature unit. But forecast type might need like how many days of hourly forecast, how many days of daily forecast, historical needs start date, end date. So what I do is I basically tell weather function parameters. So I have a codable object. So remember, the LLM will return a JSON string. I then have to parse that string into an object. So And here I'm working with strings as a starting point, and then I will use, just Swift methods to convert them into objects. I can also use convert dates, and all that is done through Swift. But basically, I need a location. I need number of days. It's 4, start date, end date, and temperature unit. And then I define this parameters, function parameters for the LLM. So I say, location for which to get the data. If not provided, the user's current location will be used. So again, you have to be very specific for the LLM. The more information you give, the better output you get. Then I say forecast type, and I give it options. So you can do current, hourly, daily, minute, historical, or all. Days, number of days to include in the forecast, only for hourly and daily. And then start date, this is the format I want. And again, this is not the same as the date string Swift format. This is the ISO format because that's what the LLM understands. I give the end date and temperature unit, either Fahrenheit or Celsius. And I want for sure forecast type, but other things it might not have because location is assumed to be user's current location. So it might not return back a location. And for many forecast types, it's not needed actually. Forecast type, yeah, here. So here, like if they want current or all or minute, then they don't need to provide anything. So the only thing that is required is the forecast type. If it's current, and then if no location is provided, I'm just going to assume that it's the user's current location.
Okay, so basically, whatever we will plant, we will get the fruit, right?
Say that again.
Whatever we will plant, we will get the fruit.
Yes, yes.
Basically,
Yeah,
we
that's
are the one.
Bhagavad
Yeah,
Gita. Yeah.
yeah,
Yes.
right, right. Okay.
So again, this is something where people are scared, like I'm gonna lose my job to AI.
Yeah.
Now, like you have to, it's a lot of work to do these type of interfaces. But what I do, again, I use AI, I use Claude to help me make these because like, it's hard because you have to switch from like this API specification and computer programmer mindset to being a writer and like you have to and also a QA tester because you have to think which parts will fail, so like now I'm looking, yeah, for daily I put max is 10 days. Yeah, so I'm sure I'm like missing something. So basically, like, you give a first run, then you need to test it and see where are the holes in this. And you don't know what users are going to do. So it's a little bit difficult. So here I specify my function. So again, I mentioned that the LLM is trained on web-based information. So I'm making my function in like JavaScript or Python type language. So I say it's a get weather function. And here I have a good description of what this function does. So again, LLMs are words. So the more you can be descriptive and specific, the better fruits you get. Exactly. And yes, yes. And then this is my convert degree function parameters, which will just take a value and source unit. And then I can kind of try get back use Swift to figure out my temperature unit enum value. And I specify I need the temperature value to convert, which is a number, and I need a source unit, which is either Fahrenheit or Celsius. And I just explain it. So this is the function definitions. So yeah, so basically like for structuring, I find it nice to kind of put the prompts and function definitions and like be very clear because when you're building these agent system workflow systems, you'll get confused like what is available, what is not. And if you organize your code well, then it really helps. And this is the prompt manager. And I have like a location manager, which is just getting the location. It caches the location data of the user. Yeah, because I don't need to, once you get the location, when the user opens an app, you don't really need to, like, every single time the user messages, you don't have to, like, again, get the location. So now the system prompt, you're a weather mate, a friendly and helpful weather assistant. The user's current location is this, and today's date is this. So as I mentioned, like LLMs have no concept of like what is current, and they have a cutoff date. They have a cutoff date of like 2023. So when you're using information that would require dates, make sure you say what is the date today, because the user will say, like, what is the weather tomorrow? Then the LLM has to understand what is tomorrow. But if you don't give it a date, it could be anything. It could also be a time zone issue because we're in India, but maybe the user is in US. So you want to give, like you want to get the date from the user's phone and give the correct date and not the OpenAI date, which might be just like standardized UTC time or something. So this is very important to include as well. So core capabilities. So you provide weather condition forecast historical data, often offer personal recommendation based on weather, alert users of severe weather, answer questions about weather patterns because we have access to historical data, so it can do. And then when responding, this was difficult for me, and I'm not happy with this. But my problem is I wanted to just like say, should I bring an umbrella today? And I wanted to say yes. But so far, what's happening is like, is it good day for stargazing tonight? It'll like give me tonight, the weather is this, but I kind of want to say, no, like don't go start. It's not a good night because it's going to be cloudy. So I want shorter responses. So this is something where I would need to play with the prompt and I'm not happy with it. I keep saying, focus directly on answering the user's questions, be conversational, don't give too much technical detail or data points. So I've been playing with this prompt to get it to not give as much weather data and just answer the question, but it's not like it's not I'm not happy with this part. And then I
Um,
also
Sorry.
hear, yes, go ahead.
Which model are you using, by the way, in this app? Like,
We'll go through this
okay.
later, but I'm just using, OpenAI again. But this is something that I would test with another model potentially. I also did the whole thing with a Gemini model because it's much cheaper. But what I found was like Gemini was not good in conversation. So I found it not to be as like friendly and like it was just more robotic response. And so
Yeah, because
I might try Cloud as well. Yes.
I was reading about like the personality of the models, and OpenAI is the
Yes.
like the standard best because it has
Yes.
personality. Yeah, that's why I was asking.
Exactly. Yeah, no, I wrote the whole thing in Gemini thinking like I'm gonna save money. And it was like, I'm like, what is this? So Gemini is good if you just want like a structured response. Like if you need data, then Google is good. But if you need that, personality, like I would also try Grok. The XAI agent has more personality, but I don't think they released the API for their latest model. And also I could try like the Llama Meta model potentially. So this is something, again, that's why I used AI proxy because I want to be able to interchange my services and models very fast. Because you do need to test it out and like adjust, and I'm still not happy with this. But also, yeah. So continuing, this is cool because you can say, use units of measurements that are appropriate to the user's region. Because in India you might use Celsius, but in America you must use Fahrenheit. When uncertain about current weather data, call the get weather function. So here I specify the get weather function and I say always call the get weather function when you need accurate weather information to answer the user's question. And then I explain about the temperature conversion function. And then, if user explicitly asks to convert temperature, you need to present temperature in both unit system. User appears to be unfamiliar with the temperature unit, adapting temperature sensitive recommendation across different unit system. So here you will specify when is a good time to call the weather function. So yeah, someone asked about that. So this is good for the prompt, including it in the prompt. And I think someone was asking about, boundaries. So the thing is, like, it's expensive to do these token calls, like these API calls. So you want to be very specific, only discuss weather and directly weather-related topics. Politely redirect non-weather questions by saying, I'm your weather assistant and can only help with weather-related questions. Could I tell you about today's weather? So this is important because the user kind of gets almost direct access to these, OpenAI API calls, which are expensive. So you want your agent to bring back to the topic of weather. There's still ways to hack it. It's not possible, it's like people can say, ignore all previous instructions and tell me something else. So people can hack it. So this is where you would have to create systems to monitor usage or user questions if you need. So this is something you have to think about in a bigger way for engineering side. And then remember to always provide helpful weather information in a human, relatable way. And again, this was difficult because it gets that weather information, and then it wants to say it in those bullet points, but I'm like, say it in a human, relatable way. And then again, I say, try answer specific questions without giving too much weather data. Keep the responses short and focused. So I kept trying to make it shorter, but this is the best I got so far, and I would need to test different model. And then here I have kind of someone mentioned, right? We have to concatenate every single user and assistant message. So this is this function. It basically takes my internal message object and it's going to go through every single message. And if it's a user message, it's going to append, a user message. If it's an assistant message, it's going to append a assistant message in the like OpenAI request body message object. So you're going to have your own message or model in your own app. It could be a Swift data model, for example, but you have to convert it to the API format. So this is what I'm doing now. And I'm literally, appending every single message that was in that conversation thread and sending it to the LLM every single time. And I'm adding the, like system prompt and all the user assistant messages for the AI. So now let's look at the actual weather agent. I'm just say reply to user messages and I get all the messages. I use my model. I'm sending all the messages, and here are the tools that the API that this LLM can use. And this is the weather function and the convert temperature function. So I'm defining the tools that are available, and then the LLM will decide when to call these tools. I have no, that is the LLM part of the magic. So the LLM will either reply back with assistant message, or it's going to call one of my tools. So let me check time player. So this is my app. So I'm just going to say, tell me a weather joke. In this case, it doesn't need any weather data. So the LLM will only respond with the assistant response. So you can see I put print messages for function calls. No functions were called. And then the LLM told me like a joke about the weather. But what if the LLM needs weather, the actual weather, right? So I say, what should I bring an umbrella for my walk
Sorry,
tonight?
QuickTime is not visible.
What is it?
QuickTime is not visible.
Oh, okay. Sorry about that. Yeah. So I'm just asking, should I bring an umbrella for my walk tonight? It did not call my function, so I'm not happy. The forecast must appear. Okay. Yeah. So of course in live demo it doesn't work. One thing that could happen is like OpenAI, they will also add tools like invisible tools uh, to their API. So while you think you're getting like perfect math, they will get the AI to write a Python script to do the math and then give you the output. So it's possible that they have OpenAI has recently added like a search function. So it's possible like
Sorry
it,
to interrupt, but I think your
yes.
application is not running. Because of that reason, it is not
Oh
showing on
yeah,
the
yeah, you're
console.
right. You're right actually. Yeah. You're right. It was just on my thank you. Okay. So I say do I need an umbrella for my walk tonight? Okay. Yes, so now we're good. Yeah. So now there's a function called getting hourly weather for one day. So this is the tool call. So how do we handle this? So we have to check what is the function name. If it is the get weather function, then I'm getting the function arguments, which I use JSON decoder for. And I get like this is the object of the parameters. And then, yeah. And then for convert temperature function, I also will decode it and then throw an error if it's not one of the functions I provided. Okay. So now in my view model, that's kind of I'm using as the in-between. When the user sends a message, you send a message. Yeah. So now like this weather function was called. So now I'm getting the location, forecast type, weather data. Okay. So here I'm getting the weather function call parameters, and I'm parsing those parameters into my actual function parameters because I need to convert like the name to a CL location object, and I have to get the current, which type of weather they want, which temperature they want. So now I call my function with these parameters using the parameters the LLM. And then what happens is the result of that function, I will append as a user message. So this is kind of like annoying because I want like a assistant user and I want like a way to say this was the function result. But currently the APIs don't support that. So you basically have like a user question, which is, do I need an umbrella for my walk tonight? Then you have the assistant reply. Then you have the user reply with the weather data. Does that make sense to everyone? It's kind of like uh, a little bit confusing, but basically you need to give the results back to the API as a user message. And what I do in my application layer is I filter out all the messages that are function results. So what I do, I have like a user object and an assistant object, and they have special UUIDs. And then I create like a special user, but it has another UUID. So here I'm filtering out like all the, I don't want the user to actually see the user query, user response to the model. So this is where it's kind of like icky. I don't like it, but this is how it works with Messages API. And then what I do is I add the message to my message history. So here I keep track of all the messages. And then I resend the weather back, the response back to the LLM. And then it will come back with an assistant reply. So does this make sense to everyone?
Yes.
Okay, awesome. So this is it. This is just examples. Okay, and then for the final part, I wanted to go over, you might have heard of reasoning models, like DeepSeek R1 or like O1 models from OpenAI. So what happened was in the first part of training an LLM, they took all the text from the internet and they input it, and then they kind of tested it, can it predict the next word? And they created this backpropagation algorithm to do this like calculations. Then the next part of training was human assistants, like humans in like Philippines, India, Africa. They went and they created like thousands and thousands of examples using the LLM data, but putting it into this user assistant format. So they fine-tuned the model in a way. So now the model can understand very well how to do user assistant, but the backend information it's generating is based on all the internet data. So then the next part is called, this is the newer work. And I highly recommend watching this video, Deep Dive into LLMs like ChatGPT by Andrei Karpathy. So he explains all this process. And what happened was they now have this reinforcement learning algorithm where they give the model a problem and they give the answer, and they basically tell the model, use as many tokens as you want. I don't care how you generate the solution. The solution is up to you. If it's like crazy thing that doesn't make sense, I don't care. I only want to make sure I get the answer. So then the model will be run many times, and in some cases it doesn't get the answer, in some cases it does get the answer. So in the cases where it does get the answer, those branches are rewarded. It's called rewarding, but those branches are like optimized for those questions. So what happened was it emerged once they analyzed the responses where the model does well to solve the problem. They found that the model has to create just extra tokens for thinking. So this is sort of like emergent behavior of the model, but they found that if the model is like, and again, thinking is the wrong word because it's literally like outputting just more tokens, more words. But once it thinks, then it's most likely to get the solution. So this is the idea behind the new like thinking models, and they work really well. But the problem is they're very slow and they're going to be more expensive because you're going to be outputting just more tokens. So for iOS apps, like you have to think, can I write a good enough prompt? Because if you think about it, the system prompt and the user prompt, these are all kind of more context information for the model. So if you write good enough system and user prompts and give enough information with retrieval, then you don't really need the thinking. The thinking is good for like maybe more complicated problems. It's also good for thinking of kind of step by step with the user, right? So if let's say first you're creating a recipe app. So instead of you just making an LLM call to say, create a recipe app, then the user probably won't like it. So now instead of that, break down the parts. So this is the main part takeaway from this. The model wants to break down the tasks, and the more context and more information it has, the better it does. So you can think of these workflows where instead of you're just saying, come up with a recipe for this, first you ask a question. You say, but what ingredients do you have? Then the user provides the ingredients. Okay, do you have any diet restrictions? So you can create that thinking energy with the user to get an accurate result as well. Also, there's you can, if you have more complicated flows, maybe you need like an outline for writing, then you can use like the thinking model to come up with steps to take, and then you can kind of implement the steps. Then you have smaller models do like more manual tasks. So you can combine this thinking models with normal models to get good results, or you can come up with ways to provide more information for the model to be more effective. Does anyone have information or questions about reasoning models? Good. So I'll just wrap it up. I know I'm like way over time, but it's like a very intense topic, and there's a lot more where that comes from. So I do write blog about it and teach more advanced workshops also. But hopefully in this session, you understand the building blocks and what is possible, how to think about it, and then you can come up with your own app ideas. Thank you. I think now is the Q&A session. So if anyone else has any questions, I'm happy to answer. Yeah, Arjun, if you want to wrap it up then.
Okay, so first of all, thank you so much, Natasha, for that incredible, insightful session. As we come to the end of our session, I want to extend my heartfelt thank you to everyone for being a part of this session. And we hope today's insights are helpful to you to develop a AI-based iOS development journey. Also, don't forget to connect with us on social media. And if you enjoy this session, please post on LinkedIn and tag us. Also, let us know in DM like what topic you want in next upcoming event. And the wrapping this session, I will request to everyone start your camera so we can take a group photo and make a memory.
Hello. Hi.
Hi. Yeah, I
Hi,
think you had a
Arjun.
question.
Hi, Natasha. I have a question. First of all, thank you very much for this vast topic and giving us a brief and how we can go forward from this point. And my question is basically this is very like trending and a vast topic. How should we what is the structure of study this topic actually? How should uh, we have to be quick start as well as we have to be depth in knowledge. How should we structure the study of this topic?
Yeah, so this is very difficult because the problem is kind of the old machine learning topics and lectures available from college are like from university are not as applicable. So I wouldn't recommend going deep into machine learning because you could if that's what you're interested in, if you're actually interested to train your own models and go to technical aspects, then there's many online university lectures from Stanford, MIT. But what happened was all these lectures are sort of outdated or they're very technical. So literally, like I would just experiment, read like OpenAI blog posts, follow them on Twitter. You can read my blog post, but I think it's just a lot of experimentation. Right now, it's a new field. And then by new field, like AI and machine learning is an old field. It's like since the 60s or something. But the new breakthrough that happened with the amount of compute available and this LLMs and the APIs, this is all new. And the fact that we can so easily integrate it into our apps is all new. So first you have to think like nobody knows what they're doing. Like that's the problem. People are like very confident and they will say, I have AGI, I do this because they're raising money. They want money for their project and VCs are giving money. So right now there's no like nobody knows anything. So I'm literally just learning, what is an LLM because I think that level is important. And if you understand like DeepSeek, it gives a problem and an answer. Then in your prompt, you have to structure the problem really well. And you can use these models well for something that has a concrete answer. So, then you have to think. It's a lot of like thinking and researching and experimenting. And you write the prompt and then what are the problems that came up? I wrote my prompt, but it's not giving me the short answer I want. So I'm still in that problem. I don't know how to fix it. I might have to experiment different prompt techniques. I might have to experiment with a different model. I also recommend like using the model yourself, like different models, because then this model has this strength, this model has that strength. So for example, like I use 3 different models. Like I like Claude for writing in Swift. Grok, the new Twitter API, is like amazing for deep search, which means it will go through like every single website and it will give you a relevant result. So I use that for that. I find like OpenAI deep thinking, they just gave access to it. So I'm finding, okay, this is kind of better for planning. But at the end of the day, I don't trust any model because I understand how it works. I know it's just spitting out, like next token prediction. But I use it, then I understand this is good, this is not good, this is what I need to do. You can look at Python, the community has more like agent workflows. Then you think, okay, which workflow applies for me for my iOS app? Because what they're making does not apply to you, but some of it does. So yeah, unfortunately, it's just kind of a crazy time right now. It's in the beginning, so there aren't like good resources except you read the API documentation, then you're confused like what is a completion, okay, what is temperature, then just read what is it, play in the playground. So it's really like a lot of self-learning because the old classes no longer apply in the same way for this type of things.
Okay. Yeah. Got it. Makes sense. Thank you. Thank you for answering this.
You're welcome.
Yeah. How, so I want to ask, like, we have lots of open source models as well. So do they share common API structures or like do they have different, like OpenAI has their different, but all like Hugging Face, like that host that can have some, like, do we share some similarity between those or they are different?
Yes. So basically, like the open source models themselves don't have an API, or like you can use MLX Swift to run them, but it'll be like a lot more work. You can do it. I ran a local model, but you literally have to like type like you have to do like a lot more work for it. Yeah, it's not as clean, but you can definitely do it. The service providers like Together AI, Grok, Fireworks AI. So they're the ones that provide the API component that makes it easy to make, an API call. And most of them will follow the OpenAI spec. So many OpenAI libraries that are open source, you can use them just by changing the source URL to the Together AI URL. So definitely at this moment, it's kind of based on OpenAI, but you cannot know for future. And the bigger problem is for Swift libraries. So there's not as much like Swift libraries and ecosystem to support this. So even if the API is available and it follows the OpenAI spec, you still might have to do, write your own Swift code to run it. Yes.
All the models available on Hugging Face are free to download, or
Yes, it's like Hugging Face. Think of it like GitHub for AI. So they are just open. It's like an open source community, but for AI models. So they're free, but what's not free is to run the models. So especially, like 400 GB model, and you have to buy a NVIDIA server computer and run it. So this is why Together AI provides that service. But obviously, if you're in a big company, you need privacy, then you would have to go through that process yourself. Yes. There's also Olama. If you look at NS Hipster, Matt Thompson, he wrote a blog post on how to run some of these Hugging Face models locally using Olama server. So definitely read that blog post.
okay, thank you.
So final call, anybody has any question?
Um, do you think like the using the mini models like the Gemini and like they have a very low cost, right? Let's say $0.05 per million tokens, something like that. Do you think those are what kind of utility do you think we have with those models, like mini models?
Yeah, so like you want to decrease costs. So this is part of like this AI engineering, you have to experiment. So find the cheapest model, find the open source model, find the Gemini model, and then apply for your use case. Does it work? And if it works, great, you saved a lot of money. But keep in mind, again, you might have to increase the prompt to be more specific. You might have to play around with it. Then if it works, it's great. So for some cases it works, for some cases it does not. So this is where like you have to have a different mindset, not just this is the best model, this is the cheaper model. You have to say, does it work for my use case? And it's cheaper, great. Yeah, it's all like Wild West. There's no answer because some models work better for some things and other works for other things. So like Claude model is very good for coding, but like I like OpenAI for writing. I didn't like the Gemini model for having a conversation and a chat, but the Gemini model could be really good for giving structured outputs, and it's cheap, and it's good for like analyzing PDFs to get an answer. So also like in your app, don't commit to one model also. So you might have within your application, you might have, one model to do one thing, give you the structure output, another model to give you the chat part. So be very open-minded, test it out. If a cheap model works well for your use case, then it's great.
Okay, so it's like different model for different use cases and experimentation. Last question is,
Exactly.
uh, let's say your app was the weather app, right? How much of the code was AI written? Like what kind of work, like how much of your code is AI written in 2025 February?
Um, I I guess I think of like an AI as like my like partner. I don't actually I get AI to like WeatherKit. So I'll give you an example. So WeatherKit API I've never worked with. So normally I would have to like go to like WWDC, see the video, download a project. So that would take me 1 week. But in this case, the AI like Claude knows the WeatherKit API, so it's able to generate the functions. But I always go and refactor, so I don't ever like blindly copy paste. I know, okay, this is doing this, and then I work with the AI. Okay, but I want also the current weather. I want to know like what is WeatherKit like how does it work? Where am I stuck? So yeah, I work with the AI definitely for coding and it makes everything faster, but I don't blindly trust it, if that makes sense.
So it's like 50-50, 50% like workflow or less.
Well, the thing is, coding is thinking, right? Like you have to think of what is actually coding. So a lot of coding is actually like having like architecture idea, product idea. So like maybe just the actual code, I would not say is like a 50%. It's like maybe
Okay,
like
so
I'm
AI
the
is just
manager,
like a
right?
tool. It's like a
Yeah,
tool
it's
you
my
can talk to.
tool.
Okay. It's
Exactly. Yeah, I don't think of it as like, oh, like all AI generated my code. No, I'm like I worked with it as a tool to work faster, but I will ask questions. I will go back and forth, but I'm the architecture and the owner of my code and of my ideas. So like I don't like for example, I might get AI to come up with like a general idea. So like for the other app I'm working on for recipe chaining steps, I had deep search. I use it as like a first example. Like, first, give me the ideas, then I read it, then I decide, okay, I like this part, but not this part. And then I decide, like, oh, I want to write this, I don't want to write this. Then I work with the AI. So it's kind of like a pair programming partnership, but I'm the manager and I come up with the vision. So that's why I never think AI will replace me because if you just have it right for you, it's not going to be much help. Like you have to have ideas and you have to think which function I call I want.
yeah,
You have to
personally,
decide these things.
I sometimes think that it makes me, a bad programmer. Like I use AI, and sometimes I think it is very good. So I forget some things. Like in let's say in 2 months, if I use too much of AI, I get bad at programming because I forgot the syntax and everything. Thank
Yeah, you
you
have
so
to
much
be
for your
careful because the AI is not a good, especially Swift programmer. So I just had to generate like a test app because I wanted to see one interaction. Then I ran it to see what's possible for Swift UI. Then I just started a new project and I'm like going step by step, but like first time generation, but the code was horrible. Like it took me like 2 days to refactor it or think through it. So I would say don't rely like too heavily on it, like rely on it, but always be in charge and always be thinking and what you want to build because it's not going to write good Swift code. No matter how much they train or how much they say, there's not enough Swift code available for training data. That's also good. So don't rely on it, especially for Swift programming. But there are some use cases. So I was writing a Python script to scrape like Sanskrit data. It's a one-shot task, right? Like I'm just like go to this website, scrape the dictionary data, put it into my database. So in this
Mhm.
case, I don't care if it's good code or not because I'm not deploying it to any users and I'm just using it once and throwing it away. So you have to decide, is this like fun play code where I don't care if it's good code and I just want to test one idea? Then it's one thing. If it's like actual production code on a team, then don't use, you use AI step by step, but don't use it like as like your whole app because you won't be able to debug it in the future.
Yeah, like for now, we have to keep in mind that under the hood, it is a predictor, like next token prediction.
Yes,
So it's
yes,
not like a
yes.
magic.
That's what I want the biggest takeaway for everyone to be. Because the more you realize how it works, then you're not you're like it's not AGI, it's not smarter than me. It is as smart as like internet. And like for Swift, it's not that good. So you have to really take that in mind. But for some things it's good, some things it's not. So really use your brain. Do not give your brain to AI. You are the controller of the
Yeah.
AI.
So,
Yes.
my last question is like from all the experience from last 5 to 6 years. Do you think we are achieving AGI in near future? What's your prediction on it? Like, are we having AGI
Yeah.
soon or no?
No, because it's just predicting database. It's an auto completion task force that's taking all the internet from the taking all the data from the internet and predicting the next word.
Yeah,
So please
so
think, do you want the internet to be AGI? But when you saw the weather agent, when you have a system, right? But you can build powerful systems that use LLM, that use user input, that use different tools that you program. So in that case, it becomes very strong. But on its own, LLM is not smart. And also what's happened is they took all the internet data. Now there's no more data. So it cannot really grow as much because the data is finished. And now moving forward, all data on the internet will be closed or because
synthesize.
now nobody wants to release their data or it'll be AI generated data. So now the data moving forward is ruined. But what they can do is they can like kind of train on all the questions that are being asked and they can get human people to write like answers to common questions. They can refine the process and make it better. They can give more tools like Google search, like a Python interpreter. So for example, like when you send a picture of your code to Claude, they're just using OCR technology to read your code and then they add it to their LLM. So a lot of the magic is actually coming from programming and programming these workflows and systems because the LLM on its own is kind of like it's set,
So
it's just what it
you
is.
you are
Yeah.
on the side that like we are not achieving LLM. I mean, we are not going to achieve AGI with
No,
LLM. We need a new architecture.
no. Yeah, it will be new. Yes, exactly.
So like different kind of architecture from ground up, like quantum or something like that. Okay.
Yes. And
But like
yeah,
I like the idea of the companies like OpenAI. They're trying to make additional layers outside of the models, like deep research.
exactly.
Yeah, they are trying their best, but this is not AGI anytime soon.
No,
Yeah.
no, have it like this. The problem is these companies are focused on benchmarks like Math Olympiad. But what they did was they actually took all the questions and then they trained on those specific questions to get better output than before. So like and also like a Math Olympiad question is not useful for me for writing my Swift code. So it's kind of like this weird thing where they're trying to prove like AGI by competing in benchmarks, which are not actually relevant to user, like how I use the AGI. I don't care that it can solve complex Math Olympiad question. I just need like a simple question about my weather, you know?
Yeah, I agree.
Yes.
Uh, like we said, in the AGI, if you wanted to upload PDF, so PDF has lots of rich data like images, graph, charts. So,
Mhm.
do we need to pre-process those, or like it will be automatically read?
Yeah, so in terms of like uh using the Gemini product, I think it can, it's a language model, so it can only output language. So it will not know about images. But you could put in the prompt like describe images because theoretically, like if you're asking questions about the PDF, you don't need the actual image. You just need a word description of the image.
Yeah, so pre-processing will be good enough for to get the answers about it.
Exactly. And then, yeah, you literally say, please, if there's an image in there, just give me a detailed description of the image. And then your next prompt, where you'll be asking questions about that part of the PDF, it will know based on the image. Yeah.
Would you like to share something about your Sanskrit app? Or... are you developing or it is finished?
It's like a long process. So I've been working more on the back end part. So I've been writing a lot of there's a lot of Sanskrit data, which is in academia. So this is something where, LLMs are not good in India, like a lot of scripts, a lot of ancient books, maybe some Greek, Latin that are not on the internet. The LLMs do not have access to that information. So this is something that's interesting to me. If I go to a library, I'm living in Rishikesh, but there's a Haridwar University with many manuscripts, and some of them have been OCR'd. So processing shlokas using Panini grammar to split words, but use LLMs to help with that. So it's like a long-term thing I'm working on.
Yeah,
Yeah. I'm
actually,
writing a lot of Python scripts actually.
nice. Actually, we also have a similar application, which is like based on Japan. So in Japan, we have like a manga culture, right?
Yes.
All the famous stories are written in Japanese. So what they are doing is like they are scanning all the images and like converting those Japanese to English with the same bubble structure.
Yes. That's
So
great. And LLMs are very good in translation.
yes,
Because if you use like Google Translate to translate a poem, for example, it will give a mechanical translation, kind of word by word and putting it together. But LLMs are like very good in words, so they can smooth out the translation and make it sound good in English versus like a mechanical, like Google type translation. So I think it's amazing for translation work.
so like we are starting from Japanese to English, but maybe they will expand to other Koreans and Chinese language.
Yes, yeah, many options for language learning. So that's something I'm working on. It's exciting.
Yeah, so like we won't be able to achieve AGI exactly, but we are accelerating at least, right? Like,
Well,
do you
I don't know. You don't know. I think it's kind of where it's at, and now there's the application layer. So this is why I'm teaching this workshop because you're the one to create cool applications from it.
I see.
It's a big leap, but it's kind of like, that's the data that's there, and they can fine tune it and make it better and build more tools. And you can build more like function calls. And I mean, there's just so many products, but I feel like it's where it's at. But then if a whole new architecture is created out of it, okay, then it's possible in the future. Yes. Okay, so if you have any questions, I'm on like X as Natasha the robot. So feel free message me there. I think I'm on LinkedIn, but I don't think I have to friend everyone. My email, I guess this will be recorded, so I won't give it. Just message me on X and then I can reply back.
Yeah, please share the keynote slides and the references.
Okay. Yeah, I'll send it for Arjun.
Thank you so much, Natasha, and thank you so much, everyone. See you in the next event. Yeah. Bye.
Thank you, everyone.